In this video, we're going to have a look at how we can use our devices or our calculators to visualize the derivatives of functions. So first thing I'm going to do is I'm just going to switch my calculator on, and then I'm going to go into graph mode. Now that I'm in graph mode, let's think of a simple function to do a derivative of. And I think that the simplest function that comes to mind is a linear function. So I'm going to go, let's say y equals 3x plus 2. Then we'll hit graph. So of course what we expect to see is a linear line that goes up the screen with a gradient of 2. Now let's see if we can find the derivative of this function. So I'm going to go exit, and then to find the derivative of this function here, what I'm going to do is I'm going to go down to y2, and then I'm going to press option, I'm going to press calc, and then I'm going to use this derivative notation here, d over dx. Then I'm going to say that I want to find the derivative of y1, not 11, and then I'll go like that. Now if I plot this, what I'm going to expect to see is I want to see a straight line. I want to see a straight line of y equals 3, because I know if I do the derivative of 3x plus 2, the derivative of that function is simply y equals 3. So doing that, and then we'll go to zoom, we'll go auto. There we go. So what we can see is that we've got this blue line, and then we've got the derivative of the blue line, so this red one here, and it's going to be at y equals 3. To check it, go to gsolve, then we'll go, or how can we do this? We'll put in xcal. There we go. And for a value of y, well, they're all like that. Should go ycal actually. Always get that one confused. We'll say when x equals 1, what's our value of y? And lo and behold, when x equals 1, our value of y is 3. If it wants to come into focus, like so. So this has been a simple example. Now let's go for something less trivial. We'll go back and we'll get rid of these two functions here. Yes, I want to get rid of that, and yes, I want to get rid of this. And rather than go for a linear function, let's go for a cubic function. So let's go x to the power of 3. And we'll make it a bit more difficult than that. Go minus 3x squared plus x plus, we'll move it below the x-axis by, let's say, by 3. And now graphing that, we've got something that again looks rather funky. Now we'll move it out a little. Yeah, so we've got something rather interesting looking, shall we say. So let's go back and we'll use the functionality in the calculator to find the slope of this curve here. Now to do that, I'm going to go option, and I'm going to go calc, and I'm going to go d over dx. So change in, we'll go y1 with respect to change in the dx. And then I'm going to leave this guy here unattended. Now, if I plot both of these functions, we're going to see a cubic in blue here, and then we expect to see a quadratic sort of looking function, or an order 2 function in this red one. So let's have a plot. And lo and behold, we see the functions that we're expecting to see. So let's zoom it again. We want to get more, we want to see more of it than that. That's better. So of course, as we see, the blue function here is cubic in nature, and the red function is quadratic in nature. So definitely what we're expecting to see. Now, we can go one better than that. We can take let's look at the derivative of the red function as well. Whoops, let's go back. And then for y3, I'm going to go option, then I'm going to go calc, then I'm going to go d squared something over dx squared. Now I'm going to put in y1. I'm going to leave these values of x unattended. And then consider if in blue we've got an order 3 polynomial. In red we've got this second order because the derivative of the blue function here is a quadratic in nature or second order. The green one itself we're going to expect to see a linear function. So if I hit graph, lo and behold, our blue function is still cubic in nature, our red function is still quadratic in nature, and our green function here is linear in nature. So this has been a video of how we can use our technology to graph the derivative of functions.